So I thought we'd talk a minute about how we got here. And this is not the only way we got here, but it's one of the ways that government sort of got involved. There were some papers, a couple of papers back in probably the late 60s. One of the authors' name was Artemis, I forget the other one. And they were suggesting that man could affect the environment. And at that time, the whole scientific community said, you're crazy. You know, they dismissed it, a lot different from today. But it was largely discredited by the scientific community. Well, Reagan ended the Cold War with Gorbachev. Well, one of the ways he did that is, of course, he tore down got the Berlin Wall torn down. But there were some guys out at Livermore Labs, headed by Dr. Edward Teller, that came up with the idea of Star Wars. You remember Star Wars? We're all old enough to remember that. And they never really pursued it to the point of implementation of satellites in orbit with UV lasers that could burn up a warhead. But it so scared the Soviet Union, they decided they couldn't win. And that's one of the reasons they kind of sort of gave up, was because of that. Anyway, when President Reagan left office and Clinton came in, the Soviet Union had held an election. Yeltsin got elected. It was going to be a democracy, and we're going to have a big peace dividend. So in part of that peace dividend, Clinton started closing military bases. He closed 2 in California, I remember, and several others. But he also sort of went after nuclear research. He said, we don't need this research on nuclear weapons. Well, you know the history. Weapons used to be tested in the Pacific, above ground. First one was in New Mexico. And then they had a peace treaty, no more in atmospheric nuclear testing, so it went underground. And the Energy Department, U.S. Energy Department, became the biggest mining company in the world I'd ever seen. They dug all kinds of tunnels in the Nevada desert, and sort of like the spokes of an old wagon wheel. So they would instrument the ends of the spokes into the tunnels, and they'd set the weapon off at the hub, and they would get a little data before it all got destroyed of what the weapon was doing. Neutron count, all that kind of stuff. Then they wanted to end underground testing. Well, that was okay because the labs had developed computer programs and models that were so accurate. If they came up with a new design, they could merely run it through the computer and figure out what it did. They didn't have to go test it. So they had these Cray computers. You remember Cray? Supercomputers, especially at the Oak Ridge National Labs, ORNL. But when they heard that, you know, peace dividend, we're going to cut the military, we're going to cut research, they went scratching their heads for how could they keep people from being fired and the weapons labs reduced in size, and they came up with, we'll model the atmosphere. We'll model the climate. These people that were saying man can affect the climate, we'll show by our models they can affect the climate, and we'll have security, and global warming sort of entered the back door of the government that way. Next slide. I don't think I can hit your thing. So Newsweek came up about, this was mid-70s, I think. Yeah, mid-70s, that's what I have on this. Maybe I was right when I made this slide. Anyway, they were claiming, the scientists were claiming, that they had this massive amount of data. It was even hard to keep up with it. Evidence was so big, and they were unanimous in the view that we were going to have an ice age. Things were going to get cold. Crops wouldn't grow, productivity goes down, all that kind of stuff. And even the National Academy of Sciences warning of disaster. NOAA predicted this drop in temperature from 43, I can't read it from here, 45 to 68. And they were claiming that, well, the layman doesn't understand this, but this really little small changes in temperature are really quite significant. We're going to get cold. So they were pessimistic that they could get the government to do anything. I wish we were that way now, right? They should do something. And one of the things they suggested was you take airplanes and you fill them up with soot, and you sprinkle it over the ice in the Arctic and the South Pole, and that would absorb sunlight and keep us from going into the ice age and keep the ice melted. How different it is today, is it not? Next slide, please. Casey, yeah. So there was a big debate, and it's been going on, of course, but this Dr. Frederick Seitz, was a very famous scientist then. He was head of the National Academy of Sciences, and president emeritus of Rockefeller University, and on the Council of Foreign Relations in the government. And he was saying this wasn't really global warming coming. And the interesting thing was, that was in the foreword to a book called Hot Talk, Cold Science, Global Warming Unfinished Debate by Fred Singer. Fred Singer turns out to be one of the biggest advocates against global warming that our nation has produced. And I'll talk more about that a little later, but he's written a bunch of books, and here's 2 of them, and I had a lot more, but I loaned them out and they didn't come back, which is kind of normal, I guess. The interesting thing was, though, there was another one I got recently, and it's called Unsettled. And it's by a fellow by the name of Stephen E. Koonin. And you've probably never heard of him, but he was Obama's chief advisor in the Energy Department. And he got his graduate degree, his PhD from Caltech under Richard Feynman. Do you remember Richard Feynman's name? He was almost like Einstein. So he was well grounded in the science. But once being with the Obama administration for 8 years, he wrote this book, Unsettled, because he looked at all the data coming in through the Energy Department, and he noticed that things were exaggerated a lot. There's a thing called the International Panel of Climate Change, the IPCC, and every year or every couple of years, it's part of the UN. They come up with this report of global warming, and they look at all the scientific data, the papers that have been produced, and they go through those things, and they don't really tell you honestly what the authors of the papers said. And he noticed that. They exaggerate. They exaggerate a lot. If the author says there's a small chance that man may be doing something over here in this corner of the universe that may be affecting climate, they turn that into man is affecting climate, and it's going to be. So he's written an entire book, and it's a pretty hard book to read, hard for me to read. But he goes into a lot of the details of that. He really never says man's not causing anything, but he makes it so statistically impossible that you kind of get the picture. Anyway, can I have the next slide, please? Casey? There was a petition going around some years ago, back when they were having the Kyoto meetings, and they looked at evidence or opinions for and against global warming. And this Oregon petition was actually started by a guy named Art Robinson up in Oregon, and he's now a state senator in Oregon. He's also a PhD physicist and an MD doctor. Guy's got a lot of background. But anyway, a lot of people signed that petition, about 20,000 at that time. That was quite some time ago. And 18,000 of them were scientific engineer degree people. Over 5,000 of them were PhDs. The IPCC came up with statements from 2,000 signatures. Not all of them were scientists. In fact, not too many of them were. And most of them were on the payroll. So, this thing expanded. Can we go to the next one? This is kind of interesting. This is part of the Oregon petition. My name's on it somewhere, but it's not on this slide. But there's a guy here named Glenn E. Shaw, PhD. He's a good old friend of mine. We graduated together at the University of Arizona. And he was at the Geophysical Institute in Alaska for his whole career. And he's my age. He's 82, I guess now. Retired. But he testified before Congress. He did a lot of stuff trying to fight off global warming. And of course, he wasn't terribly successful like other people have been. But there were a lot of people saying, this is crazy stuff. The next one, Casey. This is what the petition says. And it basically says man is not really involved in any of this, if there is any global warming. But notice the signature. It's a little bit hard to read. That's Edward Teller, the Star Wars man, the father of the hydrogen bomb. He disagreed with this global warming stuff. But is anybody listening? Not too many. You hold the next one? I know it's a chuckle, is it not? They're finding well, astrophysicists can do this, or astronomers, and other people don't look at Mars, but they're finding global warming on Mars. I don't know how many cars are there, and how much CO2 they're emitting, but it's probably the sun, I would think. Now, Mars' atmosphere is 99.99% CO2, nothing but CO2, basically. And there's really no other source on Mars. So if it's just sitting out there with the sun shining on it, what's changing its temperature? The sun, which is so easy to understand, but you never hear about it. Next one. So where is the sources of CO2? You might not have guessed, but most of it's in the ocean. It's dissolved in the ocean. It's the same carbonic acid that is in a Coca-Cola or a Pepsi or soda pop. And it's about 50 times the amount that's in the atmosphere. And there's not much in the atmosphere, so 50 times not much is still not a whole lot. Volcanoes are a pretty big source. If you remember back in, and I forget the year, but a few years ago there was this big eruption in Iceland. And airplanes couldn't fly from New York to London because of the stuff in the air. Well, the geologists that examined that came to the conclusion that that one volcano emitted more CO2, or at least as much CO2, as mankind all over the earth does in a year. There's 200 active volcanoes throughout on the surface of the earth. They're all leaking a little bit, and sometimes they have the big explosion. So that's a big source that people don't think about too much. Decaying vegetation. Plants absorb CO2, build their leaves and stuff, and then when they die, they give it back. It's like a cycle. But that's not as big a source as some of these others. So they now say, well, man's doing it too, but it's really very, very tiny, if detectable at all. So what affects the climate? Mostly it's direct radiation from the sun. The Earth has no real energy source within itself other than a little bit of radioactive decay in the core, which is terribly, terribly small compared to anything else. And the solar activity has always been left out of the models, but it's getting better understood now. It's fairly obvious now that when the sun's active, flares, sunspots, all that stuff, Earth gets warmer. And when the sun's inactive, it gets cooler. There was a time back in about 1600s and then into the 1700s called the Mander minimum, and then later followed by the Dalton minimum. The Mander minimum was a period of 70 years. There was no detectable sunspots in the sun. Very inactive. It got cold. What happened? They couldn't grow grapes in England anymore. The people living in the southern end of Greenland, the island of Greenland, they used to raise crops for food. Too cold to raise crops for food. They all moved away. They haven't moved back. Just a few Eskimo villages that are supplied by ship from outside. So it used to be warmer, but it got cold during that period. And then it was followed by another minimum in the sun called the Dalton minimum, and that's when George Washington had his troops at Valley Forge and they almost froze to death that winter. If you look back at the data from now that they bored an ice core all the way through Greenland, it's about a mile and something deep or more than that, I think it was. But if you examine that ice core, they came to the hole that the ice came out of, they came to the conclusion that Earth was, for 3,000 years, was a lot warmer than it is now. And at this minimum, in the sunspot, it was colder than it's been in 3,000 years. And we really haven't come out of that totally. So everybody's worried that we're going to burn up, and it was hotter before than it is now. Kind of crazy. And there's the solar magnetism and cosmic rays is another thing that's come up recently, and it kind of goes like this. The sun, when it's very active, the magnetic field of the sun spreads out through the solar system. And the magnetic field is strong enough that when cosmic rays, which come from the galaxy, try to come into the solar system, they're deflected quite a bit. Well, the deflection of those rays they're really high energy, huge energy. We don't have atom accelerators that can approach the energy of some of these cosmic rays. They spawn millions of particles when they hit the atmosphere. All those particles are nucleation sites for water. So they make clouds. When the sun's active and those rays are deviated, you don't get so many clouds. So the Earth heats up. When the sun gets inactive, magnetic field collapses, more cosmic rays hit the atmosphere, more clouds are formed. Clouds are very effective reflectors of solar energy. So if the Earth's a little cloudier, it gets cooler. And that explains everything. Nobody's really said that's scientific truth yet, but it is a probable cause for a lot of this stuff, and it ties the things we know about the history of climate right to the solar activity and what we measure as sunspots and stuff. So the Earth itself, and I used to go into the, whoops, could you go back one? I'm not through yet. Okay, thank you. The Earth itself is part of this cyclic problem. The Earth's orbit is not round. It's oblong. Not a lot, 6% or so, but it goes through being round periodically and then goes back to 6%. Also, the tilt of the Earth on the axis determines whether it's summer or winter. Right now, when it's summer in the northern hemisphere, we're at the furthest point from the sun. And when it's summer in the southern hemisphere, they're the closest. When that happens, the ocean gets hotter when we're close to the sun and the southern hemisphere is tipped toward the sun. The ocean gets warmer and it gives off CO2 just like a Coke going flat. You take it out of the refrigerator, open it up, let it warm up, CO2 goes out. So that's one of the things that happens with the orbital cycles. Magnetic field also has some influence, but they haven't figured that out yet. They know that the sun's field does. They think probably the Earth's field does too, but nobody's come up with anything very good. And the volcanoes that we already mentioned. They claim man is the big culprit because of burning fossil fuels, but it's probably absolutely negligible. And we have to breathe. What are we going to do if we don't breathe? Save the world, right? That's what Gates is trying to do, is kill off everybody but 600 million. And the land use itself makes a lot of difference, at least for local temperatures. Give you an example. It's hard to understand large numbers. But if you look at the sun, that's a good example. The sun is producing energy by taking 4 protons in the center, combining them to make one helium nucleus or alpha particle. So 4 protons become 2 protons and 2 neutrons. Well, if you weigh those, the 4 protons weigh a little more than the combined 4 protons do that make the helium atom. That's called a mass defect. If you multiply that by the speed of light squared, you get how much energy is given off. So if you take the sun's luminosity and divide by the speed of light squared, you get how much mass the sun is losing. Probably a surprising number to most of you. It's about, nearly anyway, 5 million tons per, what's the next word? Second. Tick 5 million, tick 5 million, tick 5 million. Every second, 5 million tons. If you had the sun on the scale, that's how fast the weight of the sun would be going down. 5 million tons a second. Now that sounds like a big number. And some of this, what they claim, well, this airplane dumped so much CO2 when he flew to wherever. And that's a big number. Well, that big number doesn't mean much when it comes to the sun. It takes the sun about 40 million years to reduce its mass by the mass of the Earth, which is about 1/1,000,000th of the sun's mass. You could not measure it anyway. There's nothing that would tell you that's what it was. So 5 million tons a second sounds like a lot. It's not compared to the sun. So we have to keep that in mind when we're talking about CO2. Go to the next one, Casey. So what's in the atmosphere? Dry air. Take the water out. We don't have much water around here. Nitrogen's most of it, 78%, a little over. Oxygen's the other 21% nearly. Well, if you add those two together, you only get 1% left, and most of that's argon, an inert gas. Carbon dioxide is not much, 4/100th of 1%. Pretty small number. And this stuff about methane from cows, it's so small, nobody would ever have to worry about it. If you add the water back, the water's always there to the degree of about 0.1 to 3% with a clear blue sky, no clouds or anything like that. There's no such thing as Sahara Desert that's absolutely dry, but it's close to dry. Can we have the next one? I plotted that on a linear scale. So when you do that, of course, you can't really see the CO2. It's so tiny compared to everything else. Go to the next one. If you try to plot the increase in CO2 that they say that's the Industrial Revolution and man has caused, well, you can't really see that either. It's just down in the line of the graph. And the next one's kind of interesting. If you were to take 10,000 molecules of air, grab them out of the air, spread them out on a piece of paper. Now, don't count these little green, blue, whatever color they are, circles. Each one is a molecule of air. And there's probably, since I got it square, it's probably 996 or something, but then 9,000, not quite 10,000, it's about 10,000. So that's CO2. And they claim that man is responsible for this one in the last 100 years or so. Is that ridiculous or not? It's a little more than, there's a little bit of something there, I'll show you. Go to the next one, Casey, please. This is the Earth at night from their satellites. Notice that up here, all the land is, and down here, most of the water is. So that explains when I was talking a while ago about the Earth being tilted toward the sun, southern hemisphere in the summertime when it's close. This heats more, and the CO2 comes out. We're close to that situation now, just about there. It'll be 100 more years or something before it's exactly there, but the Southern Ocean is giving up CO2 like a Coke going flat because it's getting a little warmer because it's getting more radiation. So, kind of crazy. So, go to the next one, case, please. So we roll it down. The Southern Hemisphere has more water, so the Northern Hemisphere has more land, and when it's nearest the sun, the stuff boils out. That's basically the bottom line here. It's released into the atmosphere. So it's presently close to this configuration, as I said. So basically, the Earth really breathes CO2 in and out, depending on how the orbit changes, other things. But it's in a fairly long cycle. But man has very little to do with it. You add up all the CO2 man produces, it's insignificant, sort of like 5 million tons per second to the sun. It's insignificant. So even though we still burn our fossil fuels, and Al Gore keeps saying we're going to burn up, which never has happened, and he got it backwards. The early data probably wasn't as clear as it could have been, but when they do tree rings and they do ice core data and stuff, they tend to find that the CO2 increase comes after the temperature increase. Al Gore went around saying the other way. History shows that CO2 goes up and then the Earth gets warmer. Absolutely backwards, absolutely wrong. Of course, he's never going to say the truth. Next, the greenhouse effect. If the Earth's atmosphere were perfectly transparent to infrared radiation, the heat, there would be no greenhouse effect at all, like the planet Mercury. But the atmosphere does cause a general warming of the Earth than you'd expect from a totally clear atmosphere to infrared. And that increase is called the greenhouse effect. Without that greenhouse effect, no life could exist on Earth. We would be a totally frozen planet, which could be kind of scary. You know, we'd be praying for CO2 or something. Next, Casey. So this is the kind of black body curve, if you know what that means, but it's pretty close to what the sun puts out. And this is what the Earth re-radiates at longer wavelengths. Right here is visible light, and this is out heat, in the heat range. you had to take this curve and take 1/1,000,000th of the sun's radiation to plot it on the same scale. So it would be a million times higher if we just use the raw numbers. So the next slide, this is the most important one in the talk. This shows energy coming in, energy going out, and these curves here show the shape of the radiation sort of at the Arctic poles and mid-latitudes and at the equator. It's a little hotter at the equator, so the curve is shifted back a little bit. But you look here, this is the total absorption in the atmosphere as a function of wavelength down here. Notice that this window, this is called the atmospheric infrared window. All astronomers look through that when they're looking at infrared stars from the surface of the Earth. Can't see out any other way because everything's blocked. And the thing that's really blocking it is this water vapor. This is what water vapor does. This is carbon dioxide. It has one line that falls in this region at 15 microns. If you figure out that scale down there, it's logarithmic. It's kind of hard. But notice the total absorption, or the absorption is total there. And this fellow in this book kind of makes the analogy. He said if you had a big piece of glass and you were outside the atmosphere and it was coated with a coating that let just this 15 micron radiation through, you'd have to paint it black. There's no radiation coming through. The atmosphere's absorbed it all. Now, if you add a little more CO2, what happens? Nothing. Do you have to paint it black again? Not really. It's already black. It's already. Spectroscopists say the line is saturated. Now, there is a little bit of difference if you add CO2 here. And the difference is there's a very minute widening of that. And that's because some of the atoms are moving fast enough that they absorb by the Doppler shift off of line center a little bit. Terribly minute. But they use that. And the way the models work is they say, okay, if we add a little CO2 and it gets just a little bit warmer, there'll be a lot more water vapor. Water vapor does the absorption. Water vapor, that'll make the Earth heat up. They don't count for clouds. They don't count for a lot of things. The models are, even with these big computers, are so terribly bad that any astrophysicist or anybody modeling anything would look at it and say, I don't think so. So that's one of the most important points, is it doesn't matter if you add more CO2. It doesn't matter. Nothing's going to get really hotter because it's already, quote, saturated. And could go to the next one, please, Case. Professor Linsden was the head of atmospheric sciences at MIT. He's one of the most renowned atmospheric scientists in the world. He's retired now. But this is what he said. Even if all the other greenhouse gases, carbon dioxide, methane, to disappear, you'd still be left with nearly all of the current greenhouse effect. And other people have said similar things. You could take all that stuff away. It's still there because water dominates everything. So the next one, I replotted this thing again, but here I did a little different. Geologists estimate how much oil there is in the world, in the earth, and how much reserve there's there, and how much coal, and how much natural gas. So they added all that up and assumed it was all burned at once. And they add that CO2 to the atmosphere. Sounds like a huge amount, doesn't it? Well, there it is. The only way to get it above that line is to multiply it by a factor of 6. Remember the sun, 5 million tons, doesn't really make any difference. Doesn't make any difference. I don't know why people don't know that. So the next one. You might remember there was a guy at Penn State, and I forget his name right now, but he came up with this hockey stick. This is years, and this is the data they have from tree rings and such. And this is what the climate models that they do show. He came up with this hockey stick, which turned out to be totally fallacious. They should have put him in jail. He caused so much controversy over it, but it was later shown to be nothing, sort of like Russia finally became a hoax. And this is the Garso C data. But you can see that down here, about when Washington was freezing to death at Valley Forge, we really haven't come out of where we were back in the so-called Middle Ages maximum. Let's go to the next one. So ask the question, if you wanted to know the temperature, the average temperature of the Earth over time, we don't have a clue what it is. But here's an idea, a Gedanken, a thought experiment like Einstein and Bohr used to fight over quantum mechanics with. But the Earth's surface is about 200 million square miles if you multiply 4 pi r squared or whatever the radius is. So if in the middle of each of those square miles you erected a temperature sensor, put it 6 feet above the ground, made sure that the sun never shines on it so it doesn't get influence from the sun going in and out, but leave it open enough that the free air can circulate. So you want to get the free air temperature without interference from the sun. So you have 200 million of those, okay, and you put them on a big computer, and every 24 hours, you take the data and add it up and divide by 200 million and record an average instantaneous Earth temperature for that day. Say a day. You could do every 6 hours, whatever, but plot that average up for some number of years, maybe for 100 or maybe even just for 10 or 20. And if a global warming is real, you would see that average temperature go up or down a little bit over that period of time. We don't have anything anywhere close to that kind of data about temperature. I mean, people just say, oh, it's 98 degrees. Okay, well, everybody accepts it's 98 degrees. That's not an average temperature over the Earth, not even close. This would sort of give you that, but it would take, I don't know, 200 or 300 years to try to do that. It's insane. But Fred Singer, the guy who wrote a couple of these books, I'll mention him again later, but he pioneered satellites, Earth satellites that looked at weather and wrote a lot of these books. That satellite data doesn't correspond to Earth data from temperature thermometers on the Earth. So here it is. Next slide will show you some of the data they've taken from satellites went up about mid-70s, 78, 79. And they also launched balloons. But the data is fairly consistent between those two. And actually, the temperature's been going down from that measurement. It hasn't been going up, it's been going down. If you look at, next slide is a place in California. I think this is Maryville. Did I write it down? Maybe I didn't. Anyway, the temperature at that station has been going up, while balloon data, global cooling, has been happening with the satellites and the balloons. That's what they claim. Well, why is that? If you go to the next slide, there's a thing that you might have heard, the heat island effect from cities. There's kind of a graph that shows kind of what that means. When you're out in the country, with no buildings and stuff around, the temperature, if you put up a temperature station and measure, as you go into cities, it starts going up. And in center city, it's the highest. The reason for that is all this asphalt, concrete, glass, rooftops, cars running. Cars actually put out a lot of heat, but it's the engine running and the radiator cooling it, and that hot air being pulled through the radiator gets heated. So if you have a lot of cars in the city, it's going to be a little hotter just because of man in this case, but it's not CO2. Turns out they don't actually correct for any of that because they really don't know how. And so it shows up in the temperature data, and they say, no, it doesn't affect anything. Well, there was a time, and I forget exactly how many years ago, NASA published some data for the Wisconsin, Michigan, Great Lakes area that showed the temperature was going up. Well, some enterprising scientists got a hold of the actual data package and went through and looked at the temperatures. There were a few 600s, there were a few 300s scattered around. Now, you know, anybody that knows anything about computer programming, you can say if t greater than 120 or some reasonable number, kick the data out, don't average it in, but they averaged it in, and NASA finally admitted they'd made a mistake. They called it a mistake. Whether it was a mistake or intentional, who knows, but anyway, that's what happened in that instance. So if you go to the next one, people have tried, and this is in California, tried to figure out how much warming effect this heat island thing does as a function of how big the city was. And they came up with a graph like this, and it's nearly a half a degree from going from low population to high population. So those are sort of, quote, measurements. Kind of true, probably. So if you go to the next slide, the satellite data, in this case, shows the temperature of Atlanta, Georgia in 1972? And this is a lot later, 20 years later. That difference is nearly 9 degrees from where that used to be to there. And these went up. And that's just people, just growth. So there's no way to probably correct the data we have. But the data we have is scarce. Remember when Soviet Union kind of collapsed, a lot of the temperature data, we had about 6,000, I think, points over the Earth to measure, not a lot. And a lot of those were in Siberia. So when Russia collapsed and a lot of those stations went off the air, those colder numbers weren't there that pulled the temperature down. So they said, oh, the temperature of the Earth's going up. I mean, stupid stuff. I mean, really, literally, ignorant stuff. But, you know, if you've got a cause, you do anything you can. So, in case if you go to the next one, this is kind of interesting. This is Marysville, California. I got it off different while ago. I thought I was here. There's the temperature station, and it used to be by itself out in the wilderness. They've, you know, asphalted everything. They built buildings around it. They got air conditioners running on it. And if you look at the temperature data as a function of, I think that's over nearly 100 years there, sure enough, it's going up. What would you expect? Look at the next one. This is 50 miles away in Orland, California, sitting out in the field. Nothing's real close to it. They've built around it, but, you know, it's not asphalt and concrete and all that stuff, and air conditioners running. And the temperature's actually not gone up at all. It's kind of gone down and plateaued out. 50 miles away, not very far. And there's a lot of that. If you go to the next one, I just picked a few. This is in Minnesota, in McMinnville, Tennessee, Cimarron, New Mexico, really on down there. And I can't read that one. South Dakota. And you can find, if you just look at individual spots, cities all over the place, you find this everywhere, that you don't really see global warming in any of this data. And even in northern Mexico, where they had a bunch of data, it's just flat. There's nothing been happening. And if you go to the next one, this is southern Greenland. It's been pretty flat too. Lately, in the next one, in Greenland, a lot of different air temperatures, sea temperatures. Everything is really trended down, not up. Kind of insanity. So if you look at a lot of the rural areas, just separate out the data from rural areas, you get a curve sort of like this. And if you include cities, and this is for the next one is several cities, the biggest cities in Australia, but you see they're going up. And it's just from this heat island effect around the cities, averaged into the rest of the data. Let's see what the next slide is. Oh, this one's interesting. So the models that they run at Oak Ridge, and now there's a big place in England that does it. They've been predicting, you know, the Earth's going to get hot. Well, while the temperature data, especially from the satellites, has been saying it ain't happening. So why is there such a difference? Next, you have to ask yourself the question, what are the data anyway, the temperature data? Are some of the temperature measurements accurate, more accurate than others? Are modern measurements now better than the historical measurements we look at? Are the measurements in the US better than in Russia, China, Europe, so on? Do the data need some sort of correction? Well, yeah, probably. Was it near some hot spot or heat source like that one I showed you at the airport with the air conditioners running and blowing hot air out? Or biased in some way over the years? How skewed is the world average data by most thermometers being historically located in the northern hemisphere rather than southern hemisphere where there's more water, or in or near cities where the growth affects them? Can it ever be sorted out? I don't really know. I mean, as a scientist, I don't know how, unless I could do 200 million things simultaneously all over the world and get a good coverage and average it over a long time, I might come to the conclusion, but even then, it'll probably go up even if it didn't really go up because of cities growing and surrounding some of these sensors that are close to cities now but be engulfed by the cities later. So probably not anything to really worry about actually, but it's a tough thing to deal with. We go to the next one, Case, and this is from Professor Linson. And you can read it, but I'll read it for you if you want to hear it. The dirty secret is that global warming is driven more by the search for funding than for the search for any scientific truth. Big science was set adrift, and like other beneficiaries of the Cold War, it's desperate to sustain its funding. That happened at Oak Ridge. So global warming had all the key attributes of the next big cause. It could be used to frighten the politicians and the public, using threats of catastrophic consequences to extract billions of dollars, our dollars, for research to prevent it. They're not spreading the soot on the North Pole yet. The science was immature, in fact, terribly immature, and the door was wide open to all sorts of proposals and projects by scientists promising the solutions. High-performance computers were the tools, and the projects promised to be a long-term, career-sustaining effort. Getting funds was easy, and Professor Linson just done all his career. He's been fighting against this, but he's not really gotten very far compared to all the big calls out there. It's another religion's what it is, another religion. Saving the planet had a nice ring to it. So, and this is my last summary slide. The actual temperature measures probably fail to support any global warming at all, much less man-made one. The global temperature data are likely biased by uncorrected heat island effects from population growth, or just ignore it. Global warming is a computer model prediction, and that's all, and it's not a very good one. Most of the variables are really unknown. What do you put in there? One of the scientists at Smithsonian Institute estimated that if we knew about a million parameters that needed to go into such a model and we ran it for 100 years, we might learn a little bit. Other than that, throw it out, forget it. Doubling the CO2 as its present rate would take 300 years, and remember, it'd have a negligible effect because the line's already saturated, nothing else happens. And the human activity at most is like a 1 or 2% of all the CO2 that's in the atmosphere. So fundamentally, the sun's driving everything. It's the only real energy input to the Earth, and the Earth responds to it. It's purely simple. And it's been doing that for a long time. So that's kind of the summary. I wanted to read you, and I don't need to have slides, but some of the things that have gone on recently, fairly recently. You find this in newspaper, you find it on television. In '89, the New York City highway, they predicted, would be underwater by 2019. Did that happen? In 2000, they predicted that children won't know what snow is anymore. Tell the people in Texas last winter that. 2004, they said Britain will be Siberia by 2024. Well, they've only got about 6 months to go. 2008, climate genius Al Gore predicted ice-free Arctic by 2013. That was 10 years ago. All the Arctic ice is supposed to be melting. And Prince Charles, he's another climate genius, says that we have 96 months to save the world. That was in 2009. And the UK Prime Minister said 50 days was all we had to save the planet from an absolute catastrophe. So climate genius Al Gore now changed his prediction. The ice-free Atlantic will not occur, Arctic will not occur until 2014 instead of 2013. And then in 2014, he changed it to 2015. And in 2014, they predicted that it was only 500 days before climate chaos. And in 2006, we were going to have super hurricanes that we couldn't stand up to. 1988, world's leading climate expert predict lower Manhattan will be underwater by 2018. See, that was a while ago. 2005, Earth will have 50 million climate refugees by 2020. Well, they were Mexicans. They didn't figure it out. 2000, snowfalls are now a thing of the past. Tell Texas that last year. 1989, the UN warns that the entire nations will be wiped off the face of the earth by 2000. Probably some of them should have been, but they weren't. And in 2011, the Washington Post, the dear Washington Post, predicted that the cherry blossoms will be blooming in winter. It'll be so warm. Unbelievable. One other thing I want to read you. This was published, you won't believe this. Oh, you will. In the Washington Post, one of our favorite newspapers, right? And it was taken off the AP, Associated Press wire. The Arctic Ocean is warming up. Icebergs are growing scarcer, and in some places the seals are finding the water too hot, according to a report to the Commerce Department yesterday from the consulate at Bergen, Norway, because you can go up near the pole at Norway. Reports from fishermen, seal hunters, and explorers all point to a radical climate change. Heretofore unheard of high temperatures in the Arctic. Expeditions report that scarcely any ice has been met as far north as 81.5 degrees. What is that, 8.5 degrees from the pole. Soundings to a depth of 3,100 meters shows that the Gulf Stream still is very warm. Great masses of ice have been replaced by moraines of earth and stones. The report continued, while at many points well-known glaciers have entirely disappeared. Very few seals and no whitefish are found in the eastern Atlantic, while vast shoals of herring and smelts, which have never more ventured so far north, are being encountered in the old fishing grounds. Within a few years, it is predicted that due to the ice melt, the sea will rise and make most coastal cities uninhabitable. Now here's the kicker. That was published 2 November, 1922. There's no common sense left. This is ridiculous, worse than ridiculous. Anyway, that's about all I had to say.